Hello and welcome to Maths with Mr Amison. In this video we'll be practicing ordering fractions, decimals and percentages. If you need to recap how to convert between fractions, decimals and percentages, then please watch my previous video about converting between fractions, decimals and percentages. I'm going to go through the example on the left and then I'm going to let you have your turn. So you'll notice the first thing I did to order this mixture of fractions, decimals and percentages was convert them all to the same format. And generally converting them to decimals is the simplest format to do. So we had 0.3, that was already a decimal. Then we had 1/3. So what I did was I used the bus stop method to be able to figure out that 1/3 was 0.333 and it carried on, so 0.3 recurring. And I wrote 0.333 just to have at least 3 digits, so having 3 or more digits after the decimal point is a good idea when you're trying to order fractions, decimals and percentages when you convert from a fraction to a decimal. That way you can compare with the other fractions and decimals more easily. 33%, well, to get that to a decimal, if you recall, we divide by 100, and to get 3/8 to a decimal, we did 3 divided by 8 using the bus stop method to get 0.375. So once we have those as decimals, then I put them in this table where this is the ones, this is the tenths, the hundredths and the thousandths. And I did this so that it's really clear to see. I could just write the numbers one on top of the other, but I'd have to make sure the decimal points lined up and the digits were in line with each other. Notice that when I wrote these out, I put a 0 in the hundredths column and a 0 in the thousandths column for 0.3. That's because 0.3 is the same as 0.3000000, and it carries on. So we can fill in any missing parts with zeros. And that really helps us to compare those more easily. So you can see here the 3 in the tenths column, all of them have a 0 in the ones and a 3 in the tenths. So there is no difference between them in those two place values. But in the hundredths place value, here we have 0 hundredths, these two have 3 hundredths, and this has 7 hundredths. So we know that this one here, the 0 hundredths, is smallest, so 0.3 is going to be our smallest number. Then we have the two numbers that have 3 hundredths. Now this one has 3 thousandths as well, but this one has 0 thousandths as well. So we have this one, the 33%, as our next biggest number, followed by the 1/3 as our next biggest number after that. Finally, our largest number then, with the 7 in the 7 in the hundredths, has to be 3/8. Okay, your turn. Copy that down, make sure you understand where it all comes from, make any notes that you need to, then have a go at putting these 4 in order, starting with the smallest. Have a go. So to go through these, we have 0.45, which is already a decimal. We have 44%, which can be converted to a decimal by dividing by 44 by 100. We have 4/9, which we can do the bus stop method for. 4 divided by 9, which gets us 0.444, and it carries on, so 0.4 recurring. And then finally we have 0.4, which is already a decimal. If we put this in the table format, so we have the ones, the tenths, the hundredths and the thousandths all lined up, you can see that the 0 in the ones column is all the same, the 4 in the tenths is all the same, and here we have the lowest digit in the hundredths is the 0, so 0.4 is the smallest. Then we have the 4s in the hundredths, so these two are the same. We have to look in the thousandths. This is the next smallest, 44%. And then we have this one because it was the same number of hundredths, 4 and 4. And this was 4 thousandths, so 4 ninths. And finally, the 5 was the largest number in the hundredths column, so 0.45 is the next one. Here's another example for you then. So in this case we have all fractions. Now when we have all fractions, it's not the most efficient thing to do to convert them to decimals. In this case we can just compare the fractions. Now if you look at the 11ths and 12ths, they're all quite similar. So we have 5 11ths and 6 11ths. Well, clearly 6 11ths is bigger than 5 11ths, which I wrote first. 6 11ths is bigger than 5 11ths. Now we have 5 11ths and 5 12ths. So we have 5 pieces in each of these fractions. 5 is the numerator. But here we have 11ths and here we have 12ths. If you think about splitting up a bar of chocolate into 11 pieces or 12 pieces, you can figure out pretty quickly that the 11 pieces, each piece is going to be bigger than if we split the same bar into 12 pieces. So 5 pieces of the bar that's split into 11 will be more than the 5 pieces of the bar split into 12 pieces. So 5 11ths is bigger than 5 12ths. So I could add that on the end there, with 11ths being bigger than 12ths. Now 8 and 12 would be an easy one to find a common denominator for, so we can convert these two fractions to the same thing, to the same denominator, So if we multiply the 5 and the 12 by 2, we'd get 24ths. If we multiply the 3 and the 8 by 3, we'd get 24ths. 3 3s are 9, so 9 24ths. 5 2s are 10, so 10 24ths. And you can see there that 5 12ths is bigger than 3 8ths. So I can add that onto the end there. That 5 12ths will be bigger than 3 8ths. So we can see that the order is from the smallest. If 5 12ths is bigger than 3 8ths, then 3 8ths is the smallest. Then 5 12ths is the next biggest, then 11 12ths, then 6 11ths. And the symbol here, if it's pointing to the right, that means bigger than. If it's pointing to the left, it means less than. Alright? Just some useful information there for you to know. So, put these in order, starting with the smallest. First of all, copy that down, make sure you understand, and then have a go at this one. So to go through these ones, we have 7 15ths and 8 15ths. 8 15ths is clearly bigger than 7 15ths. We have 8 pieces instead of 7 pieces, and they're 15ths, so they're all the same size. And then we have 7 16ths as well. Now 15ths are clearly bigger than 16ths because something split into 15 pieces, each piece will be bigger than something split into 16 pieces. Finally we have 3 fifths. Well, 3 fifths we can convert to 15ths by multiplying the numerator and denominator by 3. So we have 9 15ths. And that right there is clearly bigger than the 8 15ths. Therefore we can put them in order: 7 16ths smallest, then 7 15ths, then 8 15ths, then 3 fifths. So I'm going to give you some questions now where you have to fill in the symbol. So pointing to the right being bigger than, equals, or pointing to the left, less than. I'd like to fill in the missing symbols to make these make sense. 0.4, is it bigger than, equal to, or less than 0.40? Okay, and continue with that. For question 5, you will have to fill in the missing integers. If you recall, integers are whole numbers. They can't be fractions. They can't be decimals. So they have to be whole numbers. So to go through these answers, for question 1, the 4 here is in the tenths, the 4 here is in the tenths as well, so they're the same. For here, this one, the 7 is in the hundredths, this 7 is in the tenths, so this is smaller than this, so we need less than. 8% is the same as 0.07, therefore this is smaller, 0.08, similar to the 0.07, the 8 will be in the hundredths, and here the 8 is in the tenths, so this is again smaller than the 0.8. Question 2, 3 sevenths and 4 sevenths, because they're both sevenths, the pieces are the same size. Here we have 4 of them, so this one is bigger than this one, so this is smaller than this. For this one, we have 3 sevenths and 3 eighths. Sevenths are bigger pieces than eighths, and if we have 3 of them for each of them, then it means this fraction is bigger than this fraction. For question 3, we need to find common denominators. So here, 7 and 6 don't have any common factors. We can just multiply them together to get a common denominator of 42. So multiply these by 6, then we get 18 over 42. These by 7, we get 14 over 42, so this is bigger. 3 sevenths and 1/5. Here we have a common denominator of 35, because 7 and 5 don't have any common factors. So if we multiply these by 5, we get 15 over 35. If we multiply these by 7, we get 7 over 35. So 15 over 35 is clearly bigger than 7 over 35. For question 4, 5, 6 and 7 ninths. Here 6 and 9 have a highest common factor of 3, which means that the lowest common multiple will not be those two multiplied together. Their lowest common multiple in this case is 18, so we can convert them to 18ths. We need to multiply this denominator by 3 to get 18, so 5 3s are 15, 6 3s are 18, so 15 18ths. And we need to multiply the numerator and denominator here by 2 to make 18ths, so 14 over 18. 15 18ths is clearly bigger than 14 18ths. Here we have 5 6 and 0.84. We could convert the 0.84 to a fraction and figure it out that way, but if we do 5 6 into a decimal, 5 divided by 6, we end up with 0.83 recurring. 0.83 recurring, using the bust up method we could do that. And that is less than 0.84, because in 0.83 recurring, the 3 in the hundredths column is smaller than the 4 in the hundredths column here. For the missing digit here, if we convert all of these to over 21, 2/3, we'd have to multiply the denominator by 7. So the numerator times 7 is 14. So 14 over 21 and 9 over 21. This 14 over 21 has to be bigger than this, and this has to be bigger than 9 over 21. So something over 7. So whatever the numerator is, it would have to divide by 3, because I have to multiply this by 3 to get to 21. So the number between 9 and 14 that divides by 3, the only number there is 12, so 12 divided by 3 is 4. So 4 sevenths here, which makes sense. Here we need this fraction to be equivalent to 2 eighths, so we need to get from 2 to 3, we times by 1.5. So to get from 8 to 12, we times by 1.5 as well. So 8 times 1.5 is 12. For 2 eighths to be bigger than the numerator over 5 here, well, if we convert these to the same denominator, common denominator, we have a common denominator of 40. 8 times 5. 2 5s are 10. And 5 times 8 here. So we'd need to have a fraction here that is smaller than 10 40ths, and we'd need a number that divides by 8, and the only number less than 10 that divides by 8 is 8, so we have 8 40ths or 1/5. And it makes a lot of sense in another way, because this is 2 eighths is a quarter, which is 0.25. And 2/5 would have been 0.4, so 1/5 at 0.2 is the only answer. For the final one, here we have the same number on the numerator. We've just got it as algebra this time, but we have sevenths and fifths. Now sevenths is split into smaller pieces than fifths, and we could try it with any number we want. 10 divided by 7 is less than 10 divided by 5. It makes a lot of sense. Here we have n over 7 and 2n over 14. Now, if we want to convert them to the same denominator, we could multiply the numerator and denominator of this fraction by 2 to get 2n over 14, or divide the numerator and denominator of this fraction by 2 to get n over 7 Either way, you can see that these are identical, they're exactly the same. Alright, thanks for watching, hope you found it useful. Bye for now.